have an equation here, v square equal to u square plus 2as. Okay, v square equal to u square plus 2as. So you have already seen this equation in your 9th standard or 10th standard, I don't remember actually. So there's an equation, this is the third equation of motion. Clear? This is the third equation of motion, v square equal to u square plus 2as. Okay, how many terms? There are actually 3 terms, v square, u square and 2as. Okay, listen. So we have to check the correctness of this equation. For that purpose, take each of the term. The first term is v square. What is v? V is final velocity. Final velocity. Whether it is final or initial, it's velocity. Okay, you don't have to bother about the whether it is final or initial. It is velocity itself. Then u. What is u? Velocity. Another velocity. Initial velocity. So v is velocity. U is also velocity. Again a. What is a? Acceleration. Acceleration. And s is nothing but displacement. Clear? Then first of all, take the terms. So first term is v square. So we have to find the dimension of v square. So dimension of v square, right? So dimension of v square is equal to dimension of v the whole square, right? Simple. Dimension of v the whole square. So what is the dimension of v? Velocity. It is L t raised to minus 1. Okay. So the dimension of velocity is nothing but L t raised to minus 1. L is length, t is time. So you know that, right? L t raised to minus 1, the whole square. Okay, the whole square. What is AB the whole square? What is AB the whole square? It's nothing but A square B square, right? So applying that theory here, what will you get? It will be L means L raised to 1. Actually, what is happening here? Actually, see, this is A raised to 1 and B raised to 1, right? So what are you doing? You are multiplying this powers, right? So 1 into 2, 2, again 1 into 2, 2. Just write the number here on the top of this. Very simple. Or multiply, that is here it is L raised to, L means L raised to 1. So multiply this 1 and 2, you will get L square again. Okay, then L square again, minus 1 and 2, t raised to minus 2, right? Minus 1 and 2, minus 2. So t raised to minus 2. So what is the dimension of v square? What is the dimension of v square? What is the dimension of v square? Dimension of v square is nothing but dimension of v square equal to dimension of v, the whole square, equal to dimension of v is L t raised to minus 1, the whole square. Then it is L raised to 1. L means L raised to 1, L to the power 1. So 1 into 2, 2. That is L raised to 2 minus 1 into 2, t raised to minus 2. Right? Okay. The same principle can be used to find the dimension of u square. Next, what is the dimension of u square? Dimension of u square equal to dimension of u square equal to dimension of u the whole square equal to L t raised to minus 1, right? The whole square, L t raised to minus 1, the whole square, equal to L square t raised to minus 2, right? So your dimension of u square equal to dimension of u the whole square. Again the same process, same concept, nothing else, same concept. Okay, so again L square t raised to minus 2. Next we have the third term, that is 2as. Okay, always remember any number. Okay, so whether it is 2, pi is a number, right? 3.14, again 0, 0, then 3, 4, minus 1, minus 2, 1 by 2, 1 by 3, whatever may be the number, all the numbers are dimensionless. Numbers are constants, right? 2 is always 2, it's not changing. So all the numbers, just now remember this thing, all the numbers are dimensionless. Okay, what is the dimension of 2? Nothing. It is m raised to 0, l raised to 0, t raised to 0. So numbers are dimensionless. A number has no dimension. So during dimensional analysis, you don't have to take the number. If there is a number in that equation, you don't have to take it. Okay, just leave that. Then take the quantities after that number, or quantities proceeding that number. Okay, so here I have 2 A's. Here I have 2 A's. So we don't have to take the 2, just take the A and S, the product A's. Okay, so what is the dimension of A's? Okay, dimension of A's. Okay, you don't have to take the 2. Okay, it's a number, just leave that. So it will be dimension of A into dimension of S, right? Okay, A into B is AB, A into B, that is AB can be written as A into B. In some, this is like normal bracket. The parenthesis that we are using in mathematics. Okay, it's like normal bracket. Okay, so treat these brackets as like normal brackets. So A and S will be equal to dimension of A into dimension of S. So dimension of AS. What is dimension of A? Acceleration. What is acceleration? Dimension of acceleration. It is L t raised to minus 2. So it will be L t raised to minus 2 into, what is the dimension of displacement? L. Dimension of displacement is L. Okay, so I will write the remaining here. So dimension of L t raised to minus 2 into L. So we have L into L. What is L into L? What is L into L? L square. L into L is nothing but L square. So which is equal to, L into L is L square t raised to minus 2. Clear? See, so listen. So we have 3 terms like V square, U square and As. V square, U square and As. What is the dimension of V square? L square t raised to minus 2, right? What is the dimension of U square? Again it is L square t raised to minus 2. And what is the dimension of As? It's also L square t raised to minus 2. So all the terms, whether all the 3 terms, V square, U square and As. As means 2 As. 2 is dimensionless, so you don't have to consider that. So V square, U square and As, all the terms have same dimension. All the terms have same dimension. That is L square. What is the dimension of U square? I mean V square, L square t raised to minus 2. Then it is U square, L square t raised to minus 2. Again 2 As or As. L square t raised to minus 2. You can see, you can write either As or 2 As. Okay, you can write either As or 2 As. Both are same. So we can write that dimension of V square equal to dimension of U square. Again it is equal to dimension of 2As or dimension of As. Okay, so all the terms, the dimensions of all the terms, the dimension of all the terms are equal. The dimension of all the terms are equal. So this equation is dimensionally correct. When you write when you do the problem, finally you have to write this word like dimension of all the quantities, or sorry, dimension of all the terms are equal, so that the equation is dimensionally correct. Okay, the equation is dimensionally correct. Okay. So this is how we solve this problem, this type of problem. So first of all, you you have to find all the dimensions of all the terms. Okay, if there are 5 or 6 terms, you have to find the dimensions of all the terms, then check whether all the dimensions are equal, then we can say that that equation is dimensionally correct. Okay, I think I'm clear to you. So this is very simple. Okay, you can score marks easily from this area. So it's very simple. Okay, so dimension of v square equal to dimension of u square equal to dimension of 2a. So the equation is dimensionally correct. Okay, we will do one more problem. Okay, so we'll do one more problem. Okay. Next we have another equation here, half mv square equal to mgh. Okay, half mv square equal to mgh. Here m is mass, v is velocity, g is the acceleration due to gravity, and h is height. Okay, so m mass, v velocity, g acceleration due to gravity, and h is nothing but height. So half mv square equal to mgh, only two terms. What are they? Half mv square is the first term, the term on the LHS side, left hand side, and mgh, that's the second term on the right hand side. So first of all, we can find the dimension of the term in the left hand side of the equation, that is on the LHS, half mv square. Okay, so you don't have to bother about the dimension of the number because it's dimensionless. Okay, so we have to find the dimension of m into v square. Okay, these are the two quantities, mass and velocity, square of velocity. So m into v square. So what is the dimension? We have to find the dimension of mv square. Or you can also write the dimension of half mv square, but it is not necessary. Okay, whether you can write it's mv square or half mv square, but you don't have to take the dimension of half because it is dimensionless. So next, mv square, which means dimension of m into dimension of v the whole square. Okay, the dimension of mass into dimension of velocity the whole square. What's the dimension of mass? Simply m, capital M, right? M raised to 1. What is the dimension of velocity? It's nothing but L t raised to minus 1, right? L t raised to minus 1. So mv square, dimension of m into dimension of velocity, L t raised to minus 1 the whole square, right? So m into L t raised to minus 1 the whole square. L is nothing but L raised to 1. So this 1 into 2, again 2, right? L square. And here t raised to minus 1 the whole square, right? So this minus 1 into 2, minus 2. So you will get m L square t raised to minus 2. So what is this? Half mv square. It's kinetic energy, right? So what is the dimension of energy? M L square t raised to minus 2. Again, next we have another term here, mgh. Next we have to find the dimension of mgh. Okay, mgh. So what is m? M is nothing but mass. And what is g? G is acceleration or acceleration due to gravity, and h is the height. So dimension of mass into dimension of acceleration due to gravity into dimension of height. What is the dimension of mass? Again it is m. See, acceleration due to gravity, basically it is acceleration. Okay, so do not have to worry about it's not a different quantity. Actually it is acceleration of an object under the influence of gravitational force. So simply basically it is acceleration. Clear? So the acceleration that is a, and the acceleration due to gravity g, both of them have the same dimension, that is L t raised to minus 2. L t raised to minus 2. Okay, so both have the same dimension, both are same dimension, actually both are same. Okay, acceleration, whether it is due to gravity or due to some other force, it is acceleration. Okay, then so next, height is, what is height? Actually we are measuring height in terms of centimeter or meter, right? right. So it's basically it is length. It's length. So the dimension of height is L, length. So here we have L into L. What is L into L? It is nothing but L square, right? L into L is nothing but L square. So it will be M L square t raised to minus 2. M L square t raised to minus 2. Right. So we have half the dimension of half mv square, or mv square is ml square t raised to minus 2, and the dimension of mgh is also ml square t raised to minus 2. Therefore, the dimension of half mv square or mv square equal to, so the dimension of mv square is equal to dimension of mgh. Therefore, this equation is dimensionally correct. This equation is dimensionally correct. So this is all about dimensional consistency of any equation. Okay, how to check the dimensional consistency or dimensional correctness or the correctness of an equation. Okay, we can do a lot of problems here. Okay, but it is simple. All the method is same. The method to do each and every problem is same. We will do problems, more and more problems later. Okay, so next we are going to the next section, the next application of dimensional analysis, that is how to derive or how to find the relationship between physical quantities, or how to derive an unknown expression, an unknown equation of a physical quantity, how to derive an unknown equation of a physical quantity using dimensional analysis. Okay, so next we are going to do that. Okay, clear? So next we are going to discuss about another application of dimensional analysis, that is deriving an unknown expression or equation involving physical quantities. Okay, so let's start with the problem. Here I have a problem. Find the equation for time period of a simple pendulum or simple pendulum if it depends on mass of the bow, that is m, length of the pendulum, that is L, and acceleration due to gravity, that is G. Okay, so what is the question? Find the equation for time period of a pendulum. I think all of you know what a pendulum is, right? A pendulum is an oscillating system to oscillate. What is oscillation? To and fro motion. It consists of a bob, a spherical bob, suspended from some point by a length. By a string. Okay, and the bottom of the string we have a bob. Okay, so the length of the pendulum is the length of the pendulum, is the length from the point of suspension to the center of the bob. Okay, and it will oscillate like this. And time period is the time required to complete one oscillation. Okay, we will learn this thing later, but our now it is not the pendulum is not the actually now we have to derive the equation for what? Time period of pendulum. Okay, so the concept is based on dimensional analysis. So we have to derive the time period of pendulum. So it depends on mass of the bow and the length and acceleration due to gravity. So to express the dependency of time period. Okay, let us assume time, let t be the time period, capital T be the time period, t be the time period of the pendulum. So it is given that it depends on mass, length and acceleration due to gravity g. So the dependence of the time period on mass, length and acceleration gravity can be expressed as a product of all these quantities, mass, length and acceleration gravity. Okay, mass, length and acceleration gravity, such as like this. Listen, that is T equal to a constant K into m raised to x into L raised to y into g raised to z. Okay, so t equal to k, a constant k is a dimensionless constant. Okay, k is a actually k is a proportionality constant and it's a dimensionless constant. K into m raised to x, l raised to y and g raised to z. Okay, so the dependence of a quantity, that is time period, can be expressed as the product of k, m raised to x, l raised to y and g raised to z. Okay, where m, l, g are the quantities. I mean, m is mass, l and l is length and g is actual gravity. X, y and z are some exponents, that is powers of mass, length and time respectively. Okay, so when a question is given to you, first of all identify one thing, for which quantity. Okay, like here we are going to derive the expression of time period. Okay, so for which quantity are going to derive the expression, for what was the equation. So when you given a question, identify which quantities expression. I mean, if you want to find the expression for time period, then take it as t. If you want to find the expression for force, then take it as f. And if you want to find the expression for velocity, then take it as v. Then the next step is equate it and make an equation like this, like t equal to constant k into whatever may be the quantities, which are related to, or which are influencing, or which are on which the physical quantity depends. Okay, and see, if time period depends on mass, length and accelerating gravity. Okay, we don't know the equation, right? We don't know the actual equation. So for that part, I mean, we don't know the equation. Actually, we don't know whether it depends on mass, or the square of mass, or the cube of mass, or it depends on length, or a length raised to -1 or -2. So that's why we are writing m raised to x, y, z. X, y, z are exponents, unknown exponents. Okay, unknown exponents or unknowns actually. So the thing is, the fact is, I mean, we are going to find these exponents actually, x, y and z. So when you find the exponents, when you find these exponents, you will get the equation, right? So first of all, write like this, that is the quantity whose equation is to be determined, that is the quantity is, here it is t, time period, equal to the quantities on which the physical quantity depends. Here it is mass, length and acceleration due to gravity. Am I clear? Okay. The next step is, this is an equation, right? This is an equation. So since it is an equation, it should, or it must satisfy principle of homogeneity. Okay, since it is an equation, it must satisfy principle of homogeneity. Okay, what is principle of homogeneity? Principle of homogeneity states that for an equation, all the terms in that equation must have same dimension. All the terms must have same dimensions. Okay, so here I already told you k is a number. It will be a number. It's actually a dimensionless constant. Okay, so it is a constant. Okay, in most cases it is dimensionless, and we can treat it as a constant. So we don't have to write the dimension of k. So just eliminate that, and we have to write the dimensions of all the remaining quantities. So what is the dimension of time period here? Actually, time period is t, right? Time t, nothing else. Okay, so it is dimension of time period, that is m raised to 0, l raised to 0, t raised to 1. M raised to 0, L raised to 0, t raised to 1. That is the dimensional equation or dimensional formula of time period. Okay, so first step is write the quantity in terms of the depending quantities like t equal to k, m raised to x, l raised to y and g raised to z. Suppose instead of length, it is given that the time depends on area. So instead of length, we have to write area here. Okay, so instead of mass, if they have given density, then you have to write density rho here instead of mass. Okay, so it depends on the question. So next step, write the dimension of the quantities. That is here. See, you can write t raised to 1 actually, but for some purpose I am writing the complete dimensional formula, that is m raised to 0, l raised to 0 and t raised to 1. I will explain it later. Then what is k? K is a constant, so I have told you, you don't have to bother about k, you don't have to write the dimension of k, just leave there. Then next, what is dimension of mass? Mass is m, right? M. Okay, m. You don't have to write the L and T terms here. Just write the L, M or all the terms in the left hand side. Okay, you don't have to include the L, T or all the terms in the right hand side. Just write the relevant terms. Okay. So M, the whole raised to X. Then L is length, right? So L, the whole raised to Y. And what is G? G is acceleration due to gravity. That is L t raised to minus 2, acceleration L t raised to minus 2, the whole raised to Z. Okay, fine. Okay, so first step is writing the equation like t equal to, or the quantity equal to the quantities upon which the physical quantity depends, that is k, m raised to x, l raised to y, g raised to z. The next step is writing the dimension of all quantities. Then next, this is equal to m raised to x means m raised to x, right, into l raised to y, simple, l raised to y, into this is l raised to z, right, l raised to z, and this will be t raised to minus 2 into z, right. So this is m raised to x, l raised to y, again L raised to, do one thing, it's very simple, just write the powers as okay, powers as like this, that's m raised to x, l raised to y, and here it is y. If it is l square, then you have to write 2z. If it is l cube, then you have to write 3z. If it is l raised to 3, then you have to write 3y. If it is l raised to minus 1, and you have to write minus y, that's all. Okay, so l raised to z, it is minus 2 into z, right, minus 2z. Okay, next, here we don't have any other mass terms, right, only m raised to x, there are no other terms, there is only m raised to x, so it will be m raised to x itself, m raised to x into, what is a raised to m into a raised to n? It is a raised to m plus n, that is l raised to y into l raised to z, l raised to y into l raised to z is l raised to y plus z, right, l raised to y plus z. So it is l raised to y plus z into l raised to y plus z into, again we have t raised to minus 2z, there are no other t terms. Okay, there are no t terms. So t raised to minus 2z. Now compare these two equations. So we have here we have m raised to 0, l raised 0, t raised to 1, right. Here we have m raised 0, l raised 0, t raised to 1, and here we have m raised to x, l raised to y plus z, and t raised to minus 2z. So comparing these two equations, the exponents or the power should be equal. Then only we can say that these two terms are equal, right? This equation is correct. So the power must be equal. So here, what is the power of mass? It is m raised to 0, right? Here the power of mass is m raised to 0. So we have here m raised to x. So we can write that x equal to 0. Simple. Here m raised to x, here m raised to 0. So x equal to 0. Right. Then here we have l raised to 0, and here we have l raised to y plus z. Right. Here we have l raised to 0, and here we have l raised to y plus z. Right. So it is l raised 0 and it is l raised to y plus z. So y plus z equal to 0. And there is one more term. So I mean there is one more term. Here t raised to 1. Here t raised to minus 2z. Here it is t raised to 1 and here it is t raised to minus 2z. So minus 2z equal to 1. Right. right? Here t raised to 1, here t raised to minus 2z. So minus 2z should be equal to 1. Minus 2z should be equal to 1. When minus 2z equal to 1, z equal to 1 by minus 2, which is equal to minus 1 by 2. So we got one exponent, that is z, one unknown z. Okay, so z equal to minus 1 by 2. We got 1, z equal to minus 1 by 2. So what actually I was doing here, see, m raised 0, this is m raised to x. So x equal to 0. Here it is y plus z and l raised 0. So y plus z equal to 0. Okay, and here it is minus 2z. Here it is t raised to 1. So minus 2z equal to 1 and z equal to 1 by minus 2, it is equal to minus 1 by 2. Okay, then now substitute this z equal to minus 1 by 2 and the second equation y plus z equal to 0. Substitute z equal to minus 1 by 2 in the second equation, y plus z equal to 0. So on substituting that equation, we will get y minus 1 by 2 equal to 0, right? Right? Y minus 1 by 2 equal to 0. Why? Because z is minus 1 by 2. So y plus z, that is minus 1 by 2 equal to 0. Okay. So which implies y equal to, when the minus 1 by 2 goes to the right hand side, it will become plus. So 1 by 2, plus 1 by 2 or 1 by 2. So we got all the exponents, that is x equal to 0, y equal to 1 by 2 and z equal to minus 1 by 2. So substitute these values in the actual equation, we will get t equal to k into m raised to, what is x? X is 0, so m raised to 0. L raised to, what is y? Y is 1 by 2, right? Y is 1 by 2. So 1 by 2 into, what is z? Z is minus 1 by 2. So g raised to minus 1 by 2. Clear? Okay. So what is m raised to 0? It is m raised to 0 is 1. M raised to 0 is 1. And L raised to 1 by 2 can be written as root L. Means square root of L. And g raised to minus 1 by 2 can be written as 1 by square root of g. Okay. How we are writing that? Listen. See, actually root x can be written as x raised to 1 by 2. Root x can be written as x raised to 1 by 2. And 1 by root x can be written as x raised to minus 1 by 2. 1 by root x can be written as x raised to minus 1 by 2. This is simple mathematics. Okay. So root x equal to x raised to 1 by 2 and 1 by root x equal to x raised to minus 1 by 2. You can write that. So, so we can find the equation like t equal to k into m raised to 0 is 1. So you don't have to write that 1. Okay. So L raised to 1 by 2 is root L and into g raised to g raised to minus 1 by 2 is 1 by root g, that is 1 by root x equal to x raised to minus 1 by 2. So 1 by root g, that is g raised to minus 1 by 2. So 1 by root g, that is t equal to k into root of L by g. Okay, t equal to k into root of L by g, right? So t equal to k into root of L by g. Okay, see, we cannot find the value of k by using this method. In almost all cases, k is a number actually. In kinetic, the equation for kinetic energy, it is half. See, half mv square. And here in exam, if you don't know the equation, if you don't know the exact equation, you don't have to write the value of k. But here actually we have the equation as t equal to 2 pi into root of L by g. So substitute substitute 2 pi for k. So let k equal to 2 pi. K equal to 2 pi. We will get t equal to 2 pi into root of L by g. Okay, 2 pi root of L by g. So this is the equation for what? time period of a pendulum. Time period of a pendulum. Okay, it's very simple. Okay, this is one of the most important concept in this chapter. Okay, a question will be sure in the exam. Okay, there will be a sure question in the exam for 3 marks or 5 marks, depends. Okay, 3 marks or 5 marks. Then, so this is an important one. This is an important thing in this. I mean, this is an important topic in this chapter. Okay, so I will explain once more. So we have time period of a pendulum. We want to derive the equation for time period. So first step, write t equal to k, a constant, into m raised to x, l raised to y, and g raised to z. Then we have to write the dimensions of all the quantities, like m raised to 0. What is the dimension of t? M raised to 0, l raised to 0, and t raised to 1. And what is the dimension of m? It is mass, it is m raised to x. Dimension of length is l, the whole raised to y. And the dimension of g, it is lt raised to minus 2, the whole raised to z. Then form an equation, equate the powers after multiplication, equate the powers. Then you will get the value of the exponents and nons. Okay, then substitute that, then write the equation. Okay, I think this is very clear to you. Okay, it's very simple. So do it. Okay, practice it and do it yourself. Try to do another problem. There will be more problems. We will do more problems later, and there are a lot of problems based on this concept. Okay, we will do one more problem. Okay, one more problem, and do practice this. Practice. Okay, then you will able to do the problem. Okay, clear? So we will do another problem, a simple problem. Okay.